All right, hello, and welcome to Thursday. We're 2 weeks and a day away from fall break, which is happening in October. So what do you need today for these notes? You need note sheet 34, a calculator, a pen, and a pencil. Later on, if we have time, we're going to make a foldable. What we're doing is we are proving theorems about triangles. Yesterday we looked at interior angles of a triangle. Today we're going to be looking at isosceles and equilateral triangles. So I got a joke for you. Hopefully you've been practicing on F1, which is classifying triangles. So we got, she always has to be right. And that's because she's a right triangle. And he says, oh, he's so acute when he's mad. And we would classify him as an acute angle because all these angles are less than 90. And over here we've got this lady. She says, you wouldn't know an isosceles if it bit you in the hypotenuse. Really, Frank, sometimes you're so obtuse. And Frank over here is definitely an obtuse triangle because his angle measures are greater than 90. And he says to Vivian, you're always right, because she's a right triangle. And their baby, what kind of triangle is their baby? That's the question. All right, moving on. In real life, these are the pyramids, the Great Pyramids of Giza. And they were built back in 2500 BC. And they were based off of an equilateral triangle, which is pretty interesting because they didn't really have any really good measuring tools. But all the sides are equal and all the angles are equal. And so the question is, if all the angles are equal, what do the angles in an equilateral triangle? What does each one equal? We'll get to that later. And then if you've ever been to Epcot Center in Disney World, the globe, spaceship Earth, that's actually based off of isosceles triangles. And what's different about an isosceles triangle is that two sides are equivalent and two angles are equivalent, not all three. Let's look at some more examples. Here we got some equilateral triangles, the yield sign, pyramid of pennies, and if you play pool, that's an equilateral triangle. If you're into art, M.C. Escher, his art is based off of equilateral triangle. And if you're into mapping GPS systems, this is the GPS antenna. And if you unrolled it, it would actually be a right triangle. Not a right triangle, excuse me, an equilateral triangle. I'm not giving you $1 for that because I corrected my mistake. Nice try, D. All right, and down here you'll see the human elbow. If you hold your elbow closed, it makes an equilateral triangle. Then when you open it up, it's actually a straight angle. Now, you all didn't know this, but you actually eat isosceles triangles all the time. If you like to eat pizza, you're actually eating an isosceles triangle. Two of the sides are equal, which means two of the angles are also equal. When you hang up your clothes, because you don't have a messy room, you're hanging your clothes on an isosceles triangle. This sailboat, if you like to sail, is based off of an isosceles triangle. The University of Tennessee banner is also an isosceles triangle. You'll see the two sides are equal and the two angles are equal as well. If you look at the front of the room, you'll see a better college, the Wisconsin Badgers. That banner is also based off of an isosceles triangle, the two long sides being equal and the two base angles. And then here's the White House, where Donald Trump lives, but Ivanka doesn't. And that's also an isosceles triangle. So let's take a look at these properties. So an isosceles triangle says that if two angles are congruent, then the sides opposite them are also congruent. So if I say that this angle is congruent to this angle, then I can say for certain that this side is congruent to this side. And you can see that that looks like the UT banner. Sure enough, and you can do it opposite too. If I say that these two sides are equal, then you can say the angles are equal as well. Now, did anybody figure out in an equilateral triangle what all the angles measure up to? Well, they're all going to be 60 degrees, and they're all going to measure up to 180. So each one of these equals 60. They're all equal. And then the sides of an equilateral triangle are congruent as well. So let's look at some examples so that we can use these properties and what we learned yesterday to solve some interesting facts about some triangles, to find those missing angles. So here we've got an isosceles and an equilateral triangle, and I'm going to use the information I know to solve for x. So first I'm going to classify this, and I'm going to classify this as isosceles simply because we know two angles, so therefore we know these two sides are congruent as well. And so I'm just going to simply go 7 equals 2x minus 11. Add my 11 on this side. 18 equals 2x. When I divide, I know that x is 9. I can plug it back in. 2 times 9 minus 11. That's 18 minus 11, which is 7. So I did it correctly. And over here I have what I call an equilateral triangle. And I know it's an equilateral triangle because all my sides and all my angles are congruent. So therefore, again, I can say 11 equals x plus 22. Because if I know this side, I know the other side is equal to it. Just subtract 22 from both sides, and I get negative 11 equals x. And if I plug that in here, negative 11 plus 22, it's also 11. So I have solved that correctly. All right, next, let's look at some more examples. Here we got an isosceles triangle. I know that because these two sides are congruent. Therefore, I know the angles opposite are congruent. And I use that as my symbol, an arch, to make sure that I label them congruent. So if this side's 68, I know this side is 68. And I'm going to call this an isosceles. Example 2 is also an isosceles. But this time, this angle here and this angle here are congruent. So I know this one's 48, and I know this one's 48, but I'm looking for the missing angle. So I'm just going to simply do 48 plus 48 plus x equals 180. When I do the math, add these, subtract it from 180, I end up with x equaling 84. And for the last triangle, once again, this is isosceles. And again, I know it is isosceles because I have 2 equal sides and therefore 2 equal angles. But I don't know this angle, and I don't know this angle. So what I can do is apply what I learned yesterday, which is the exterior and an interior angle, make a linear pair. This is 106, so this is going to be 180 minus 106. And so that is 74. And so if I know this angle is 74, then I know this angle is 74 degrees as well. Go ahead and pause this video for a U-try. And please pause the video and try these problems on your own. That way you can check your work and you're actually learning in the process. All right, if you didn't pause the video before, you're going to have to pause it now because these are the answers. And hopefully you got these answers as you worked it out. If you did not or you had any questions about where you made your mistake, please raise your hand at this time and I will come around and help you. We're moving on. All right, here are some more of the examples that I'm going to do with you. So let's look at this example. First of all, I'm going to call this an isosceles because these two angles, these two sides are congruent and therefore these two angles are congruent. So if I know this one's x, I know this one's also x. So I can say 2x plus 78 is going to equal 180. So I'm going to subtract out that 78. And I'm going to get 2x equals 102. So therefore I know x is going to equal 51. Over here I got another isosceles triangle. And in this case, I see that this exterior angle here is 139 degrees, and I know that this is going to make a linear pair. So I'm going to simply take 180 minus 139 to find this angle right here. So this becomes 7, so that's 1. So this is 41 degrees. And I know this one's 41 degrees because it's opposite this side, so that means this one, we call those the base angles. That's also going to be 41 degrees. So now I got to set up my equation. 41 plus 41 is 82 plus x equals 180. So when I subtract out that 82, I get x equals 94. 8. So again, at this point, you're going to pause for you try. If you have any questions, raise your hand. So I bet you're wondering what, if you have a triangle that doesn't have any equal sides, we call that scaling. Just an FYI. All right. Here are the answers to the you try. So if you didn't pause the video before, you're going to have to pause the video now so that you can check your work. I'm moving on. All right, let's do a couple more together. So these are a little bit more complicated. So if you haven't noticed, every time we're just adding another dimension to difficulty to these problems. So in this case, we're saying that we know this is an isosceles triangle. I've turned the triangle on its side, so it might be harder for you to see that these are the two sides that are going to be congruent to each other. And I'm just going to simply write my equation. So I know that 70 is going to equal the measure of angle 2. And up here I know that angle 2 is equal to x plus 82. And so all I do to solve this is I subtract 82 from both sides. So x is equal to negative 12. And again, your x can be negative, but what can't be negative is your angle measures. So if I plug negative 12 in here, negative 12 plus 82, I believe is 70, right? And so if I get 70, that works out because these two angles should be equal to each other. And over here, I've got, this is another isosceles triangle. So I know that these two angles are going to be equal to each other. So if this one's 66, I know this one's 66. So then when I set up my equation, it's going to be 7x plus 6 plus 132. And I'm saying 132 because 66 plus 66 is 132. And that's going to equal 180. So I'm going to add these. That's 138. Subtract it from here. And I get 7x is equal to 42, which means x is 6. And so if I know x is 6, I can simply plug that back in up here. 7 times 6 plus 6 is 48. Okay. Pause the video. Try a couple on your own. Raise your hand if you have a question. Don't skip this part. This is an extremely important part. And I know a lot of y'all like to skip it and then say, oh, I don't learn anything. Try these two problems on your own. And if you have a question, raise your hand and let me know. Hopefully you pause the video and now you're just checking over your work. So these are the steps. If you didn't pause it then, you have to pause it now to make sure that you copy down these steps. You'll see first the sum of interior angles add up to 180. Then you figure out what x is, and then you plug that back in to figure out what the other equation is. And so again, what is the difference between an isosceles triangle and an equilateral triangle? Well, in an equilateral triangle, all three sides are congruent. An isosceles triangle has two congruent sides and two congruent base angles. The angles are crossed from the sides. Right. Tomorrow you're taking a quiz on this. So today you can try the practice problems on the back of the sheet. Please read the directions because you have to do the ones that are grayed in, and then you get to choose 5 more to do. And then you're going to finish IXL F1, F2, and F3, and be ready because in a little bit when everybody's done with the video, we're going to make a foldable about isosceles and equilateral triangles. And again, a scalene means it has 0 equal sides. All the sides are different lengths. Most triangles are pretty much scalene, but anyway. All right, well, I hope you enjoyed today, and 11 days. 11 days. I can do anything for 11 days, and then I'll give you a week off. Peace.